Hello, everyone. Okay, so I'm Gergely, and after a little bit of technical difficulties, we can start with the talk. So this is when Mac is not plug and play. So I'm going to talk about LibGodot today. I'm the CTO and co-founder of Migeran. We have been working since 2007, so we are a family company, and actually we met at a Siemens Mobile development project. So we worked on this phone together, and that's actually how we met, and how afterwards we started our own business. And the funny thing about this mobile phone, that a few years ago we went to the Technical Museum of Milan, and this phone was on display as a show item. This was like a mobile phone in the early 2000s. So we are doing software development for our clients, and also we are doing our own product development. And our first own product was purchased by Intel, which was the MultiOS engine that allowed developers to write iOS applications in Java. Intel later open sourced this. It's still a community project there are still users of this project. We also worked on robots, and this is an inventory robot. It's about 500 kilograms, and when it comes after you, you kind of think a little bit different about those Terminator films. We also worked on Skype. Of course, Skype is shut down now, so we built Skype for TV sets, and also we worked for 6 years on the V8 JavaScript engine. But let's go to LibGodot. Why we started to work on LibGodot? So first, why we started to work on Godot engine at all? And most people, when they try at Godot engine, maybe they are building some small 2D games. The more ambitious people build some small 3D games. And we actually worked on an automotive project where we built an augmented reality HUD and visualization engine using Godot engine 3.x. Of course, first we went through all the usual suspects like Unity and Unreal, and also some obscure ones like the Ramses engine from BMW. But in the end, after a lengthy evaluation, we decided to go with Godot engine, a heavily modified one that we customized for this purpose. And this was actually our first Godot project. And as you can see, it wasn't your standard Godot project. It has a legacy renderer that was an ECS-based renderer with Luagit scripts, and we integrated it through GD native. And there was also a ROS1, or a robot operating system middleware below the whole thing, which connected us with all the sensors in the car. This worked, but there was a lot of room for improvement, and we needed Godot 4 for that. And luckily, Godot 4 came, and it's really a huge leap for developers in all respects. We all know that. And from our point of view, the biggest advantage of Godot 4 was the GDE extensions. And this basically is a C API that allows you to access the internals of the Godot engine from any language. Of course, there is the official C++ bindings. There will be official C# bindings using the GD extensions. It's already in the works. You can try it out. And there is also first-class support for all the other languages like Rust. And we also built TypeScript support. There is, of course, also Swift support. So no other game engine does this. So it's not possible to do with Unreal or Unity. And this is a special power of Godot that we can use to bring different components built in different languages together. So back to LibGodot. So why would we want to use Godot as a library? Of course, with GD extensions, it's quite easy to integrate other libraries into Godot, but there are use cases when we have an insanely complex system and we would like to have some really good visualization system, some 3D capabilities that come so easy with Godot, even with editing capabilities and so on. We all know this. So see, we somehow want to integrate Godot into a large system where we cannot tell the stakeholders that, okay, very nice, but let's make Godot the boss and everyone will become just a GD extension. We cannot do that. So let's make Godot a library. Just build it like a library and it's done, right? Right? Well, the issue is that we also have to control somehow this embedded Godot instance. And this is where our solution comes in. So of course we could define a completely new API that makes it possible to control Godot from the outside. But actually, we have already a solution, an API, a C API at that to control Godot, and it's the GD extension API. So the question is, can we extend the GD extension API? Can we build on it to allow a host process to control Godot? And of course, the answer is yes. So with LibGodot, it's possible to control the Godot itself, the Godot library, using the GD extension API after we have loaded it into the host process. And the LibGodot interface, what is in addition to the GD extension API, just two functions, one to initialize and one to stop Godot. And this core functionality, which I just described, was actually merged in Godot 4.6, so it's already usable. So there are actually two sides of LibGodot. One side is what I've just talked about. So how we can control LibGodot, how we can control the startup and shutdown, and of course after we have we have loaded the Godot engine, we actually have a Godot instance class that we can use to control the main loop. So we can iterate directly the main loop. We can pause it. We can have focus and resume functions that are used on mobile platforms, and of course we can also provide the input events from the host process into Godot. But the next step is that we actually want to embed Godot UI into an application. So this is not necessarily true for all LibGodot applications, but in many cases, we want to embed LibGodot in the LibGodot UIs into the UI of the host application. And this is the first prototype that we built. It was an iOS-based prototype, and it already shows that we have 4 Godot windows embedded in a Swift UI application, and it just works. So how did we do that? Basically, the main idea of this is that we grab a handle for each window, and this is a new abstraction layer inside Godot that you can use to define a window of Godot, and you can decide whether that window will be shown as a sub window inside the main Godot window, or you can actually embed it into the host application. So, of course, there are lots of different platforms supported by Godot, and we actually need to understand how to embed a Godot window into a host applications window on each of these platforms. But the good news is that we already support basically all the possibilities on these major platforms. So on Apple, on Android, all the options are supported. On Windows as well. So Windows works with OpenGL, Vulkan, and DirectX 12 as well. What is missing from the picture? Well, Linux. So Linux should be easy to support as well. It wasn't a requirement from any of our clients until now, but if anyone needs this, then please get in touch with us, and we can talk about supporting it. Earlier we had X window support working, but we haven't tested it in ages, so it might need some love to get it running as well again. We have not implemented Wayland support yet, but we looked at the Wayland API, and the good news is that the Wayland API is much nicer than the old X11 API, and it's actually much closer to the more modern operating system APIs like Apple or Android. So it will be pretty straightforward to support Wayland as well. So who is actually using LibGodot? The first major sponsor and by far the biggest sponsor of LibGodot is Zogot, and that's how Apple support and actually so too many features to count came to be in LibGodot. That's how LibGodot became a production quality system, and LibGodot with a host of Zogot specific features powers the Zogot implementation on iOS. So if and iPadOS, so you can use it on the iPad and on the iPhone as well. Another big user is React Native Godot. So we we implemented React Native Godot on Android and iOS for born.com, and they are using it in their Pengu application, as you can see on the screen. They decided to release this work as open source, which is great, and it works very nicely both on Android and iOS. They have a lot of users. We also had to find and work around some Android GPU bugs as part of this project, and those were also merged recently. I think in some Godot 4.6 patch release. And we also just finished a project for another client who required additional development on this platform, and they are still in stealth mode. They plan to release those changes when they are ready with their product as well. Okay. So there are other use cases of LibGodot. One is embedding into a Windows Qt application as a 3D engine, because Godot is much more capable than the built-in 3D capabilities of Qt. And it is used by a civil engineering company. Another use case that we know of is embedding Godot into native Android and iOS applications. And here we saw online education use cases. So when will this get into the upstream Godot engine? So as I already described, the core LibGodot is already in 4.6, so you can start trying it out if you want. There are, of course, limitations with that first version. Probably the biggest one is the reinitialization support. So it is common knowledge that once you initialized Godot, then you cannot shut it down and restart it in the same process. You have to actually exit the process and start it again. We actually fixed this in LibGodot a long time ago, and we have this reinitialization support patch ready for upstreaming, also for the current master. Of course, it's working stable in 4.6 and also 4.5 and 4.4 before that on our Migeran LibGodot branches. The next feature set is actually the UI embedding features. There is the core infrastructure, the new abstraction layer of the different rendering surfaces that we can use on different platforms, and also the Apple UI embedding support. These are also ready for upstreaming for the current master branch, and of course these are also stable in the Migeran branches as well. And we also have Android and Windows UI embedding working in the Migeran branches, and we are working on the PRs for these two for the master branch. So we are Migeran, as you can see, we have been working on Godot for a long time, and we have been working on different parts of the engine. In this talk, of course, I concentrated on LibGodot, but we have also worked on the AR and XR parts and many different parts of the engine, and we provide commercial support and feature development for around Godot and around LibGodot itself. So if you need that, we will be happy to help. And please sign up for any updates about LibGodot and any upcoming new Godot products. So if you have any questions, I will be happy to answer.
Hi, thank you for the talk. I looked at LibGodot a few years back and then didn't touch it so much, but it looks very much improved. I was wondering, we have some component tests in a project running, and right now it has a lot of headaches. Like Godot needs to be running. We can't use the Visual Studio test runner. Could you like run Godot tests, like component tests like this without opening Godot using this?
Yeah, so that's definitely possible that you can write a test harness basically that will start Godot in a process. You can drive the tests using the GDExtension API and then shut it down and even start it up again without exiting the process. So that works.
Great, thanks. I'll definitely try it.
Hi, could you please go in a little bit more detail regarding the window handle thing? Like, is it a change in display server API or is it some internal custom thing? I'm interested in
Yeah,
know that.
what we do is that we introduce a new class called the rendering native surface, and this is a base class, and for each platform we have subclasses of this base class with the platform specific implementation for that platform. For example, on Apple, we need a CA layer to be able to render into the host process. On Android, we have the A native window in this Android specific rendering native surface subclass. On Windows, this is a funny thing because you have separate things. One, depending on what you want to do, if you just want to somehow get Godot into your application, then you can just use a HWND reference and use that, but that's the easy way. However, if you want to integrate it into a QML scene graph, then that becomes more difficult, and you need to do you need to use external textures. For example, that basically in that case, Godot will render into an external texture inside in Vulkan, and we pass these external texture handles to Qt, where we wrap it back into a Vulkan texture, and then it can use it inside the QML scene graph. So this is also implemented, and with OpenGL it's much simpler. We can just pass around the texture IDs, so shared with a shared context. So if we are working with OpenGL, that's how it's done on Windows, and also it works on other platforms. And yes, finally, DirectX 12. Actually, with DirectX 12, we only tested so far the use case when we have a XAML component tree on the host application side, and we want to display a Godot window inside a XAML component. And luckily, Microsoft thought of that, and there is actually a special component which allows us to display a DirectX or swap chain inside a XAML component. So it also worked quite nicely. We have a special rendering native surface subclass for this case, and Godot just renders into its own swap chain, and it can be shared with the host application. Yeah, so I think I went through all of the possibilities. So that's
thank
how
you.
we
That's
do
really
it.
interesting.
So we are out of time. So if you have questions, search each other. And thank you.
Okay, thank you very much.